My name is Jeff Anderton. I'm the owner and founder of Teaching High School Chem, and you're here for workshop number 2 of our summer workshop series on teaching chemistry for kids with weak math skills. And so that's what we want to start with today. And so let me close out my video screen and let y'all see the presentation, and we'll go from there. All right, like I said, my name is Jeff Anderton. I grew up in Marietta, Georgia, which is a suburb of Atlanta. I have a degree in chemical engineering from Georgia Tech, but decided that wasn't for me. So I went back to school and got my second undergrad in secondary science education with a focus in chemistry. I started teaching in 2001, and I've always taught at relatively small schools, so I've always taught more than just chemistry. A lot of my teaching career, I've taught Algebra 2 and Pre-Cal. And part of why I want to do this workshop is because it's one of the things I really think I'm actually really good at. Is they always gave me the class with the weak kids for Algebra 2 and Pre-Cal. Because the mathy teachers, they would have their technically correct way of doing things, and it just wasn't very flexible for weaker kids. And where I managed to really connect with the weaker kids and help them excel. And so that's kind of why I want to do this talk today. And then I left the classroom last year to focus fully on teaching high school chem, to fully invest my energy in trying to find ways to serve chemistry teachers. There's just not a lot of great resources out there for you guys. And with my teaching experience, I wanted to be able to give you something to make teaching chemistry easier. And so today we're talking about how to teach kids with weak math skills. And so we got to start with, what is your mindset? What is your gut response when you have a weak math student in your classroom? And so just to because we've got to start off there, because our gut reaction is going to affect how we then act after that. Right, so I've run into teachers who are just kind of like, well, tough for them. They'll have to catch up, or they'll have to keep up, or whatever the case may be. Or you could just be kind of upset and say, this isn't how it's supposed to be. That teacher should have taken care of that last year, and it's not my responsibility. And just kind of, for lack of a better phrase, and kind of play victim on it and say, oh, poor pitiful me, what am I going to do about it? You could water it down. You could be like, all right, well, these kids can't do math, so let me just kind of trim the math out of my class and bring it down to their level and kind of water it down that way. And then I think there's a fourth option, and that's what we're going to explore today. For me, so much of this was shaped by one of my students. I had a student who I had in Algebra 2. He came in my Algebra 2 class and he could not do positives or negative numbers. He couldn't solve a basic equation to save his life. But he was an amazingly hard worker. It was his homework grades that's the only reason he passed first semester, because he was in the 40s on his test. And I'm pretty generous with partial credit. And I mean, it was hard. But he worked hard. He came in to see me. He got a tutor to help him with his basic math skills. And then I had him the next year again in Pre-Cal. And I remember, he went from making 40s to making upper 80s. And then one of our Pre-Cal tests towards the end of the year, he made an A on a test. And he was excited. I was excited. His family was excited. And that's what I want to see, because I'm a firm believer that the other way is to start with kids where they are and take them where you can. That we've got to work with what we're given. Because I'm a firm believer that if we take any of the other mindsets, the tough on them, oh, this isn't the way it's supposed to be, or watering it down, we're robbing ourselves of the power that we can have in these kids' lives. We're robbing ourselves of the ability to really have an impact in their lives. Because if it's tough for them, then we leave them in the dust and they don't get anything. If we say it's not how it's supposed to be, we make it all about them and their lack of experience, and we kind of basically take away our power to do anything about it. But we have the ability to do something about it. And I really learned this when my first teaching job, I taught at a small private school in Atlanta. And it was a school for kids with attention deficit and other minor learning disabilities. So I had kids with math learning disabilities. I had Tourette's. I had bipolar disorder. I had a little bit of everything. And what I learned there is I still taught at a college prep rigor. But because those kids have weaknesses, most of my grades were Bs. I had a few A's, but that was okay. I took them where they were, and I took them where they could get to. And for them, that was a B. And that was okay. And so that's kind of my mentality I have as a mindset of where we want to start. Because we have to decide what's important. What's important, is it getting through the content, or is it our student understanding? And if it's getting through the content, then tough on them will work. But that's not my philosophy. My philosophy is not about the content. I can cover content and talk to a brick wall. But my job is to teach students. And so student understanding is what matters. And so it may take me an extra day or an extra week to get them up to snuff, to get them up to speed with where I want them to be. And they may always be a little bit slower than some of my other classes that I've had in the past, but it's their understanding that matters to me. And last week, in the first workshop, if you haven't seen it, it's on replay at teachinghighschoolchem.com/workshop/replay. And there I talk about this idea of student-driven pacing. And student-driven pacing is very simply this. The understanding level of my students determines how fast I go. If they are struggling, I will take a day or half a day or 2 days, whatever it takes, to slow down and spend extra time with them and to make sure they've got it before I move on. Because I think that's what happens here a lot of times is if, like let me go back to Algebra 2, like if I've got kids who are struggling solving basic equations and I just, do it in the normal number of days that I normally teach it in, and I give them that test and I move on, what's going to happen when we get to more complicated equations? They couldn't do the basic ones. What makes me think they're going to be able to do the complicated ones? If your students can't do mole conversion, what makes you think they can do stoichiometry? And so student-driven pacing is I'm going to sit there and make sure they know how to do mole conversions and they really get it before I move on to doing stoichiometry. And part of how I do this, and one of the things I talked about in last week's workshop, is I use class time. So I would I would lecture for half the period-ish, sometimes a little more, maybe up to 2/3. And then I would give them classwork and I'd walk around and gauge where they're at, answer their questions, help them. It's a great way of helping my weaker kids, my quiet kids. It's also a great way of helping weak kids. And so I would always use my class time to walk around and help them and give them that guided practice. And what that does is that gives me the ability to assess them without having to grade a whole bunch of stuff. I hate grading with a passion. But also I think it gives them a good foundation to be able to go home and do homework because now they've practiced and they know how to do it right. And so that's kind of really, I think, the mindset that I'm coming at this with is that the mindset of helping weak math students is to come at them where they're at and then help them get to where you can. I may not be able to get to and spend as much time on my last couple of units as I would like. I'll still cover them. I may cover them very briefly, but I'd rather my kids really understand the fundamentals than I would to get through everything as in depth as I would like. And so that's kind of my mindset that I'm using when I approach this. So like I said, so take them where we can, even if it's not as far as we would like. All right, so here's my first big strategy here that I use for teaching chemistry to kids who are not so great at math. And I make it a method. I make it less about math and more about following a set of steps. And the reason why I do this is, one, I focus on this so that it it limits math phobia. When kids see math, there's so many students, oh, so many kids I've had through the years who just immediately, as soon as they see math, they're like, oh, I can't do math. And I'm like, just give it a second. Let's see if you can or can't. But they're already deciding that they're hopeless. That good old learned helplessness. As soon as they see math, they're like, eh. I'm like, hold on, slow down. Trust me, work with me. But then the other thing it does, it gives a great structure and support. When you have a method, when you have a step-by-step way of doing something, and it's a way that I, like when you see these methods, I repeat them ad nauseum. I mean, just over and over. Every time I do an example in class, I'm saying it. Every time we're going over a homework problem, I'm saying it. Every time I'm interacting with them, I'm saying it. I say it over and over and over again until they can do this method in their sleep. It's great for weak students because it gives them structure and support. They're like, all right, what's step one? Oh, I do step one. Okay, I can do one step. Because sometimes weak students, especially, they see the whole problem and they get overwhelmed. But if they have a method with steps, then oh, wait, I just need to do step one. And then they get step one. And then I'm like, oh, then they do step two. And then it breaks it into kind of bite-sized pieces that they can handle. It's also great for stronger students because you're going to have students who are like me in high school who would go so fast that I'd make careless mistakes. I mean, I remember doing 2 times 3 was 5 on a calculus test one time because I was going so fast, that I added the numbers instead of multiplying. And my teacher just shook her head. It's like, I can't believe you did that. I'm like, well, that's what happens. I get going so fast. And so these methods slowed down my strong kids. And I force my kids to slow down and show me the steps because I know they can do it faster, but I want them to slow down and get the foundation down. All right. And then I'm going to show you my 2 key methods that I use. One for conversions, which is conversions, mole conversions, stoichiometry, all that together. And then solving equations. And so let me show you conversions first. So for me, one of the biggest things I do with conversions, and this is more of a planning curriculum arrangement thing, is I take conversions, teaching dimensional analysis, conversions, whatever your book calls it. I take it out of chapter 2 or 1 or wherever it is in your book, and I move it to right before I start moles. And that way I'm teaching the skill fresh. Hey, we just learned conversions, now let's do moles. Instead of having 3 or 4 months in between when you teach conversions and when you finally start using it with moles. I did that my first year of teaching, and I just found that it was just too big of a gap. I ended up having to spend like extra days having to reteach them how to do conversions. So instead of doing that, I just moved it because that made more sense to me. Also, I'm trying to help them learn a method. And so I start with things they understand. I start with like feet and inches and miles and ounces and gallons and cups, pounds and kilograms. So I start with kind of everyday measurements. And I'm doing conversions with those so that the kids don't get so confused. That way they're not worried about the number so much as they're worried about focusing on the method. So let me show you what the method looks like. So how many miles are in 1,000,000 feet? 1 times 10 to the 6 feet. So I give them the conversion factor. That's how I always do it. I always give them the conversion factors that I want. When we get to moles, I don't. But for this first part, they don't need to waste the mental energy to remember how many feet are in a mile. So I'm going to give that to them. All right, so here's how my method works. So first part, write the given over 1. That's what I always say. So whatever number you're given, put it over 1 every time. Okay, so that's always step 1. Step 2, and this is where I'm going to differ from what you're going to see in books. Place the units first. I teach my kids, we kind of do some basic fraction work with 3 times 2 over 3 is what? And they're like, oh, that's 2. I'm like, why? Well, because the 3's cancel out. I'm like, exactly. If you have the same thing in the numerator, same thing in the denominator, they cancel out. Same thing on top, same thing on bottom. So what I say is, and a lot of times I use top and bottom instead of numerator and denominator. Just once again, I'm avoiding that mathy language that can confuse kids. So I say, all right, we got feet on top. So we're going to put feet on bottom to get rid of it, to cancel it. So those will cancel out. I'm going to go to miles on top. And the reason why I do this is because I find the number one mistake kids make when they're doing conversions is they get things in the wrong spot. And so I added this extra step to help them get things in the right spot. Because if they get the units in the right spot, they get feet on bottom, miles on top, then the next step is easy. Because then I go, all right, go look at your conversion factor. You had miles on top. What number goes with miles? Oh, 1 goes with miles. So 1 goes with miles down here. You have feet on bottom. What number's with feet? Oh, 5,280 is with feet. So it goes with feet down here. And that extra step really helps my weaker kids get what they need to get. And then I'm basically kind of like, solve it. If the number's on top, multiply by it. If it's on the bottom, divide by it. Once again, you could do the whole mathy numerator times numerator over denominator over times denominator, and then reduce that fraction. Not worth the effort. I find just simply telling them, hey, top times top. If it's on top, multiply. If it's on bottom, divide. So this one would be 1,000,000 divided by 5,280. It's going to give you 189. I do teach significant figures. So this has 3 significant figures in the answer because the 1,000,000's got 3 significant figures, and this is actually an exact number. So this has infinite. But there's 3 sig figs here, so I've got 3 sig figs here. And then they got to have the correct unit on the end. Okay, the feet got canceled out, miles left over, so miles is my unit. And so that's basic conversion for me. I generally do not use I don't use this railroad track notation. It's just a whole lot easier to do it in PowerPoint. I usually do the multiplication dot in the middle. Either way works. I know some people like the railroad track method, once again, because it looks less like math. And kids are less likely to freak out that way. And so that's my basic steps for conversions. It's a very simple method, but to me, the money step is right here. Having them do their units first. And then when they have to do a longer conversions, like let's say I wanted this not in miles, but I wanted kilometers. And they were then going to have to convert miles to kilometers. One of the things I would make them do, and you'll kind of see this when we get into moles here in a second, is I want them to think about where they are, where they have to go, and what road they have to take first. It's like I tell them, it's like, hey, guys, if you're going to go on a road trip to somewhere, don't you need to know what direction you need to go first? Don't you need to kind of like plug it in your GPS first? And so it's the same thing. I'm telling them, hey, you got to figure out where are you and where are you going and how can you get there. It becomes a real big deal in stoichiometry. All right, so for me, I like giving my kids visuals. And for me, like when we're doing mole conversions, that's a mole road. There are lots of different versions of this. This is my newest version. I used to not have this on there. I used to just have particles, which are like atoms or molecules. That's Avogadro's number. Molar mass to get to mass, and then volume of a gas at STP. I added concentration, and I'm going to redo some of my stuff in my membership file to reflect that. But I like giving kids a visual. We live in a very visual generation, but it acts as a roadmap. It helps them see, especially in multi-step problems, what they need to do. So if I give them molarity and I want to figure out, mass, or the other way around, I've got 100 grams and I want to go to, a liter solution. How do I do it? And this, they can see it's 2 steps. They go mass to moles, moles to concentration. Once again, I'm giving them some type of structure to support them. I'm giving them some type of structure that's going to help them and keep them from getting all confused as much as possible. So a lot of times for my homework, one of their questions is, draw this. And I make them draw it at least 5-6 times throughout the course of the unit, because they have to draw it on a quiz. They have to draw it on their test, because it's something that's there to help them, and I'm trying to make them remember it. I also have one for stoichiometry. I've never seen this in a book, but I use it for stoichiometry all the time. That you start somewhere on the left, you end up somewhere on the right. It's not always going to be all 3 steps, but you can have grams, molarity, or liters if you're talking about a gas. That goes to moles, and then you do your stoichiometry step, that mole to mole step, using the reaction, and then you convert it to grams, moles, molarity, or liters of B. And so I teach once again using a stoich road. And when I first start teaching stoichiometry, I literally make them draw this out. All right, what unit were you given? Oh, I was given moles to start with. So you're starting here. And then we're going to go there. Oh, and it's asking for grams. And so then they go here. And I make them draw this out, writing in whatever their reaction tells them to do. So this is always what they're starting with. This is what they're converting to. And once again, it gives them this visual that helps them structure it in their heads before they get started doing the problem. Because once again, I think especially with weak kids, they get so overwhelmed. And they want to just like, I don't know where to start. I'm like, use the diagram. What are you given? Oh, this. Where are you trying to get to? Here. Okay, use a diagram. How do you get there? And then usually that's enough. That by this point, they're comfortable enough with conversions that they can figure this out. And it's just giving them framework on how to do it. So that's conversions for me. All right, equations. Once again, I have a step-by-step method that for me is all about giving structure to weak kids and giving slowdown to my fast kids. All right, so this is a standard gas Wallace equation. At the volume of a weather balloon is 7.59 cubic meters at 101 kilopascals. Then what is the volume when it rises to where the pressure is 1.21 kilopascals? Assume constant temperature. So granted, by the time it's at height, temperature is not constant, but we're going to assume it for the sake of the equation. So the method is simply this. First, identify your variables. And I literally, like, I'll have this written on the board, and I will say, all right, what's meters cubed? What is that a unit of? And they're like, volume, because we've gone over this, or I'm trying to prompt them and teach them. Like, okay, that's volume. So we put V. And I'm like, all right, is it the beginning volume or the final volume? They're like, the beginning. I'm like, 1. So it's V1, and we'll put V1 right here. Go, what about this? What's this? Oh, that's a pressure. Is it initial or final? Like, initial, P1. And then what's this? Oh, that's a pressure, P2. And so we identify the variables in the equation. We label them in the equation first. In the question. So we label them in the question first. And that really, once again, I'm slowing down kids, because when they're, if you taught gas laws, number one mistake kids are going to make is they're either going to pick the wrong equation or they're going to put things in the wrong spot. Slowing them down and making them identify the variables helps. Then write the original equation. No numbers, no units, just write it. Okay? P1 equals V1, P1 V1 equals P2 V2. Okay? This is Boyle's law. So very simple. And so I just make them write it, because once again, the number one mistake they're going to make is put things in the wrong spot. By writing the equation like this first, it will help them to get things lined up in the right spot. So then we plug in the variables. It's literally P1 goes here, V1 goes there, then P2. All right. Hopefully, most of your kids can solve this. If they can't, then that's where they need to come in for extra help, most likely, to figure out how to do very basic algebra here. But, like, hey, clean up the right side, multiply these, then divide this to move it over, and you get a volume. See, that's even how I did this times this gives me that. Then divide, give me 634. Once again, 3 sig figs. With sig figs, by the way, what I normally do with sig figs is when I teach significant figures, I have to get it exactly dead on. But after we do significant figures later on throughout the rest of the year, it's just a matter of get within one. So like this answer should have 3 sig figs. If they gave me an answer with 2 or they gave me an answer with 4, I would accept that. If they gave me an answer with 5 sig figs, then I would count it off. They'd lose a point for not having correct sig figs. And then they also need to get the unit right. And with this, I don't deal with the whole math with the units a whole lot. I think that's more of a physics thing. Ends up being a really big headache for a lot of kids. What I tell them here is, with a gas wall equation especially, that my volume 1 was meters cubed, volume 2 is going to be meters cubed, that they're going to match. Okay, just like the pressures had to match, and if they didn't match, we'd have to convert them to match, which I don't recommend adding that if you don't have to. That's a good like honors class type thing to do, but not with kids who are struggling with math. But then, so these have to match, and then therefore the volumes also must match unit-wise. Once again, the less mathy I can make this, the better it works for them. Okay. I mean, this works for any type of equation. So just identify your variables, write the original equation, plug it in, and then solve. All right, here's some just tips on grading these. Hold on. Yes, I also do, Molly was asking, do you save instruction of sig figs until prior to mole stoichiometry like you did with the conversions? Yes. I do scientific notation, significant figures, and conversions all as one unit. That's also when I teach measurement. I mean, I may have done measurements before. Sometimes it just kind of depends on my mood that year. But significant figures, scientific notation, and conversions, I teach all those at once to give me a good foundation. All right, grading tips. Partial credit is your friend. I don't know how you feel about partial credit. I know there are more than a few tests at Georgia Tech that I would have gotten zeros on if it were not for partial credit. So here's my big thing. Especially when I first start teaching conversions, I am all about the method. I look at the answer, but it's not what I'm looking at. It's not what I'm grading. I'm grading the method. It's the given over 1. Are the units in the right spot? Are the conversion factor numbers in the right spot? Do you have the right answer with the correct number of sig figs and the correct unit? And so I'm looking at a method, and so I'm grading the method. And so, in the way I do it, just to keep myself sane, is I think I've had like one test in the last 5 years add up to 100 points. I don't do things adding up to 100 points. I just assign a point per step, and then let's say there's 153 points on the test, and you got 143 out of 153. Just put in a calculator, figure out what percent that is, and that's their grade. And that just saves me a lot of headache. And so, for example, looking at the conversion that we did before, kind of like I said, so each step given over 1, that's a point. So I tell everybody, it's like you should be able to get 1 point for every question. You should be able to put the given over 1. That shouldn't be too hard. Units in the right spot, correct. Numbers with the correct unit is another point. Final answer is a point, and then sig figs and unit is the 5th point. Okay, and so that's how I do points with those. As they get more comfortable with it, I start not giving. So like by the time we get to stoichiometry, I'm not assigning a point for this. And then these kind of get combined into a point. And so I start, as they get more comfortable with the method, I stop worrying about the method as much and start putting more emphasis on, are they just using it right? Otherwise, you just get too many things you're trying to keep track of. Same thing with equations. Early on, when we're learning it, these are a point, or you could make them each a point depending on how you feel about it. There's a point. This is a point, getting those in the right place, and then solving is a point, and then unit is a point, and sig figs. And so once again, I kind of do that same idea. By breaking it down into points, then I'm putting my grading on what I'm trying to teach. I'm trying to teach a method. And since I'm trying to teach a method, that's how I'm going to grade. I'm going to grade the method, not so much the answer. Drives my smart kids nuts. Because my smart kids can look at the question and they can tell me what the correct answer is. They can be like, oh, that's so and so many inches. And I'm like, yeah, work it. I'm like, why? I'm like, because I'm trying to teach you a method. But they'll balk at it, but it's like, guys, you got to get this method down. And I can say that, my kids who struggle in my class, it's because they refuse to learn the method. And I'll go over it with them and I'll try to explain it to them and they just balk and refuse. There's only so much I can do. But I've had kids who continually fail math classes or struggle with math classes, eking by, make solid B's in chemistry because I break it down to a methodology. I break it down into steps for them. And that's the critical piece for me. Because really, these are the two big areas where math shows up in chemistry: conversions and solving equations. And so by breaking it into a method, I'm giving my kids structure, I'm giving them framework. And like I said, my kids will hear me say, given over 1, get your units in the right place first, then match up your numbers from your conversion factor, then solve it. If it's on top, multiply; if it's on bottom, divide. They're going to hear me say that easily, close to 100 times probably before they take the test, because they're going to hear me say it over and over again. I'm saying it in class. I'm saying it when I'm helping them out, during classwork time. I'm saying it when we're doing a review. I'm doing it during help sessions. I'm like, it's how I approach it every single time. Same thing with equations, and I hold my kids to it. Once again, I'm holding my smart kids to it. That, all right, whoa, slow down. Where are your variables? What are they? Label them. I don't make them write them out like this. Let me go back to that real quick, and I'll show you. So, like I said, I would literally just write V1 here, P1 here, and P2 here. I would literally just write it on the paper in the question. That would be enough for me to say, hey, you labeled those variables. That would be enough for me. And then the first thing they would actually write would be this. Along these lines, I give my students these equations. I don't tell them which one's which because that's part of what they need to learn. But I give them Avogadro's, Boyle's, Charles, Gay-Lussac's, Dalton's law, partial pressure, and the ideal gas law. I give those to them because that's not where I want them to spend their energy memorizing things. I want them spending their energy solving the questions and knowing which one to use. And so that's a bigger deal for me. And so, I just kind of do it that way. And so that's why I do certain things that way. Let me get back to where we were. All right. So once again, if conversions are one of those things that you yourself are not super comfortable with, then maybe this will help you as well. Just get that framework down. And once again, once kids learn how to do conversions with feet and miles and inches and meters and all that kind of stuff, then when I add mole conversions, it's just a new conversion factor. It's no big deal. Usually somewhere on my conversion test, I kind of prove this by basically saying, I give them some problem like, hey, convert sprockets to doohickeys. And I give them like 3 different conversions. Like one sprocket is 2 whatchamacallits and 3 whatchamacallits is 5 doohickeys. How many doohickeys do you have? And I show them that, hey, as long as you have a conversion factor, you can convert anything I give you. And then when we get to moles, I'm like, hey, here are these new conversion factors. 1 mole is 6.02 times 10 to the 23rd particles. Hey, atoms or molecules. To them, it's just a new conversion factor. And they just plug it in like they've been doing. For this reason, I can usually, like when I get the mole conversions, it ends up actually being one of my quickest units because the kids are so comfortable doing conversions because once again, student-driven pacing. I haven't moved to moles until they're really comfortable with conversions. And now they just add it. And then when we get to stoichiometry, same thing. They should be able to do mole conversions in their sleep by now, or pretty close to it. And then all we do is add an extra step where we have to look at a balanced reaction and get a conversion factor there to go from moles to moles. It's like by slowing down and making sure they get that foundation, it then makes my life so much easier as we move on. All right. So, I shared this with y'all last time. I'm just going to go through it a little bit quicker for those of you who are new this time around. Is I see the growth of a chemistry teacher to be kind of really in 3 stages. You're here, so you're not doing this. But people who don't try to grow, they're not growing anywhere. They just stay where they're at, and it doesn't help. But as a teacher, first thing you got to do is grow in content. You got to understand how to do this. If you're not comfortable doing conversions and mole conversions, and you're not comfortable figuring out empirical molecular formulas, doing limiting reactant and percent yield, if that stuff gives you the willies, then you got to practice it and you got to learn it by whatever means you can. You got to get to the point that you are super comfortable with the content before you can even begin to really hope of truly teaching it to your kids. And then once you know it, I don't know about where you went to college, but where I went to college, especially Georgia Tech, I had some professors who were brilliant, who couldn't communicate it worth a lick. They knew the chemistry, absolutely, but they couldn't explain it to anybody, which really doesn't help a whole lot. And that's our job as teachers, is explaining. And so we have to grow, after we know the content, we have to grow in our ability to explain it. And that's kind of what I'm trying to, that's what we're doing today. We're going, how do I communicate this math stuff? How do I communicate conversions and solving equations to my kids who really struggle with this? Okay. And then growing in creativity, that's where you start adding in, like kind of like what I said, like my, sprockets to whatchamacallits to doohickeys. You're not going to find that in a chemistry book anywhere. It's just once I get comfortable with the content, once I get comfortable with the communication and how to communicate it, then like my mind gets freed up to kind of be creative and do weird, silly things. My sense of humor tends to be silly. And so I'll do kind of funny, silly things and just kind of helping my kids get it better. And then, so like I said, teaching high school chem, for me, I mentioned this for y'all last week, and I'll say this for all of these. My passion is now to help you. My passion for 15 years was helping students. My passion now is to help you. Help you be a better chemistry teacher. Help you do it better, but also help you do it more efficiently. I loved my students every year. But even when I was at a small school and I taught kids for maybe 2-3 years in a row, after 3 years, I don't see them again. They graduate, they move on. I may run into them at the store or run into their parents at the store, but they're gone. But my wife and my kids, they're going to be in my life for the rest of my life. And that's where I want to spend my time. And that's where I want to help you to spend your time. And so that's why we're doing these summer workshops. They're free. My crash course and the academy, which is my membership, both of those have costs with them. Now I'll have some discount codes throughout the summer, but for crash course, if you're struggling with the content, that's my resource for you. It is over, I'm trying to remember how many hours it is. I think it's somewhere in the 60 to 80 hours of videos to teach you how to do, what is the content. Once again, I'm focusing on the content, not how to teach it, but what is the content. So I'm actually trying to teach you. Then it's got a workbook to work through and all those kind of things. If you're really struggling with the content of chemistry, that's my resource for you. If you want to focus more on the communication and you want to be in a community with other chemistry teachers, then that's what the Academy is for. So the Academy is my monthly membership, and it's all the handouts, everything you need to do to be confident and prepared to teach chemistry and still have a life outside of school too. You got keys to help you grade things. Then you got office hours with me. Once again, I'm just trying to help you out as much as possible. And if there's something that you think would be helpful that you don't see here, email me, Jeff at Teaching High School Chem. And just email me and I will gladly, come up with something. Like for my members of the Academy, it's kind of like, hey, do you have a lab for this? And I'm like, no. Give me 3 days and I'll come up with something, and then I can do that and I can turn around and get it to you. Or, hey, do you have any more handouts on this? And if the answer is yes, then I can give it to them. If it's not, then I can make it. And that's what I'm trying to do for those teachers. I'm trying to serve them the best I can. And so next week, we're going to do looking at nomenclature, and just kind of give you a broad scope there. That's going to include, I'm going to talk a little bit about doing Lewis structures and Vesper, because to me, that's part of doing covalent nomenclature. And then we're going to talk about ionic nomenclature and how to do that. And it's another one of those areas where kids just get bogged down and lost. So I'm going to try to show you how once again, I provide structure and support, and do student-driven pacing to try to really help kids with nomenclature, to really know how to do those covalent and ionic formulas and names and going back and forth between the two. All right, so that's what I've got for y'all today. So if y'all have any questions or anything like that, then I will answer those. Even got my paper here if you need me to work out any examples or anything. So. Once again, like I said, so I'm done with my presentation. So if y'all have any questions, just type them. I'll be on for a few minutes. More than willing to answer any questions as we go along. And hope y'all found this really valuable. And I hope to see y'all next week.